Okay. Hello, Professor. Here is my lab for the comparator project. So right here I have my my main code, which displays the schematic. So it takes inputs A, B, and X, and XORs them. And this part of the module, in this part of the module, it'll take 8 inputs, 7 through 0 or 0 to 7, however you want to read it, and it'll output P. So then it has the wires P0, P1, P2, P3, P4, P5, so it can represent the XOR gates. So these first 4 XOR gates, they will take the value of A M0 and B M1 and then return it into XP0, and it'll do the same for the next 3. After that, these 2 will take the results from the previous XOR gates and put those into a new XOR gate, such as so AP0 is this first one, BP1 is the second one, and it'll result XP4. And the same thing happens here. AP2 is the third one, and BP3 is the fourth one, and it will result in XP5. And then the very last one, it'll take these last 2 XOR gates, and it'll put them into one more XOR gate at the very end. So AP4 is this one, BP5 is this one, and it'll all result in P. So if we run the schematic, we'll be able to see that a lot more clear. Wrong one. There it is. Okay, so look at the schematic. You open each of these up. You'll notice that they each have an XOR gate inside of them. So it takes the value of A, it takes the value of B, and it returns the value as X. And it does that for each of these. So these 2 each return X, and it goes here, and they become A and B. These 2 taking the values of A and B for each return X, and they become the values of A and B. Look at these ones, and they should look the same as these 2. So they take the AB values, return X, take EB, return X, and then for the very final XOR gate, they'll take it one last set of values for A and B, A being this one, B being this one, and it'll return P. So that's the schematic, and then looking at the test bench, which will run the timing diagram, you can see that this one also takes in 7 inputs and has the output of Y. So what it's going to do is it's going to run a for loop, and the reason why it's I less than 16 is because it needs 16 numbers, since it's a hexadecimal digit. So it sets A equal to I, whatever I is during the for loop, and it'll display whatever the timing diagram needs it to display, and then it finishes. So we run that timing diagram. Okay, and then right here, if we open this up, we can see the entire thing. Oh, that's not what I want to do. What did I do? Oh my god. Oh no. Oh man, I gotta restart this. Okay. What is going on? What? Okay, sorry about that. Oh my goodness. Okay, I'm not gonna touch anything else. Sorry about that. So we look at the timing diagram, and you can see for each value of A or B, it'll blank results in 0, a full square results in 1, and so they each represent a hexadecimal value. See, this one represents 0, this one represents 1, 2, 3, 4. We go all the way up to the last one. It should represent 10, and then F, F, and then E, D. So each of these little columns here represents a hexadecimal number due to the results of the test bench. So yeah, that's my project. That's it.